Hello and welcome to all students. Okay, today in this lecture we study about divisibility in shade and we discuss the point greatest common divisor and how to find greatest common divisor or GCD of two numbers. So first of all, we see a very important theorem, a statement of the theorem, and based on this statement, we have to solve some problems. Okay, so let us see. The theorem is any two non-zero integers a and b in Z have GCD and it can be expressed in the form of MA plus NB for suitable M and N in Z. The meaning of this theorem is so uh, so if I take any two integers in the uh, any two integers, then these two integers have a greatest common divisor, and we can express this greatest common divisor as a linear combination of number a and b for suitable integers m and n in the form of ma plus nb. Okay, so based on this we try to solve some problems. Finding GCD. Here we find GCD of two integers by using division algorithm. Example number 1. Find the GCD of numbers 2210 and 357. So we write the answer. Consider the given two numbers 2210 and 357. Here, if we divide by number 357 to a number 2210, then by division algorithm we can find two integers q and r, that is quotient and remainder respectively, and we know the relation between quotient, remainder, dividend and divisor. So relation among them is 2210 is equal to 357 into quotient plus remainder. Okay, so here quotient we get is 6 and the remainder is 68. Therefore 2210 is equal to 357 into 6 plus 68. Now again we divide by remainder. Again we divide by remainder 68 to divisor 357. So 357 is equal to 68 into q plus r, where q is 5 and r is 17, means remainder is 17. Therefore we get the next relation, 357 is equal to 68 into 5 plus 17. Now again we divide by remainder 17 to divisor 68, and we get the 68 is equal to 17 into quotient plus remainder. Here q is equal to 4 and r is equal to 0. So finally we have 68 is equal to 17 into 4 plus 0. In step 3 we get remainder 0. We stop the procedure of division. In the second last step, the remainder is 17 and it is nothing but the GCD of two integers 2210 and 357. Therefore, so by in notation, therefore, GCD of 2210 and 357 is 17. The same problem we can write in the tabular form. So instead of writing that much things, just we write like this. The above problem we can solve in tabular form as below. So in tabular form we make a table with columns, with 4 columns. First column is for dividend, second column is for divisor, next column is for quotient, and fourth column is for remainder. So in the in the above problem we got 3 equations, and here we need to write only 3 rows. So first row is for first equation, second row is for second equation, and third row is for third equation. So from the equation 1 we write the corresponding values of dividend, divisor, quotient, and remainder. Okay, in second equation, from second equation we write second row, and from third equation we write third row. So in this fashion we can put up the above problem in tabular form. Okay, and see here in the last row, in the cell of last row, last column, the in the red cell we have the remainder 0, and in the green cell we have the remainder 17. That remainder 17 is nothing but the GCD of these two numbers. So from onward we solve the problem by using tabular form. Consider the next example. Find the GCD of two numbers. Find the GCD of two numbers minus 1092 and 195. Answer: we know that minus 1092 and 195, the GCD of minus 1092 and 195 is same as the GCD of plus 1092 and 195. Therefore we find the GCD of plus 1095 with 195, and then our work will be over. Okay, construct table. So if we divide by 195 to 1092, in the first row we get the quotient 5 and a remainder 117. Now in the second row again we divide by remainder 117 to a number 195, In this case, we get the quotient 1 and remainder 78. In the third row, again we divide by a remainder 78 to the dividend to 117. In this case also, the quotient is 1 and the remainder is 39. So you can do on your calculator also. 39 in the now in the fourth row, again we divide by a remainder 39 which we got in this row third, divide by remainder 39 to the dividend 78. We get the quotient 2 and a remainder 0. So as soon as we get the remainder 0 in the second last row, the remainder is 39 and that remainder is nothing but the GCD of given two numbers. So in this example, so green cell 39 gives the GCD of two numbers 1092 and 195. Now let us see the example number 3. Show that 497 and 3015 are co-prime numbers. We show that 497 and 3015, their GCD is 1. So we know that the definition of co-prime, two numbers two integers are said to be co-prime if their GCD is equal to 1. So in this example also we show that the GCD of given two numbers is 1. Okay, so consider the table with columns dividend, divisor, quotient and remainder. So first of all we divide by 497 to the number 3015, and in the first row we get the quotient 6 and remainder 33. Okay, so take this remainder and divide by this remainder 33 to the divisor 497 in second row, and we get the quotient again 15 and remainder 2. In the third row we divide by 2 to the divisor 33, and in the third row we get the quotient 16 and remainder 1. In next row we divide by remainder 1 to the divisor 2, then we get the quotient 2 and the remainder 0. So our division process is over here, and the green cell in which the remainder is 1, that remainder is nothing but the GCD of given two numbers. So as the GCD of given two numbers is 1, it shows that the two numbers 497 and 3015 are co-prime numbers. So to find the GCD of two numbers, let us take some homework. Find the GCD of two numbers. Find the GCD of two numbers 1265 and 67. In second example, find the GCD of two numbers 3546 and 34. Okay, as we solve these two problems using the procedure which we have studied, which we have learned today. Okay, if you have any problem you can contact with me, and our today's lecture is over. Thank you very much.